Hello everyone, my name is M. Shanmukha Srisai Tejamanne and I am the part of Extremely Embedded System Internship Batch P7. Today, I will be presenting my internship project, which is the design and implementation of an embedded micro oven system. Through this project, I explore real world applications of embedded systems working with microcontrollers, display modules, and user input mechanisms. And I use several applications and modules in this platform as per the user feedback. In this document, I provide an overview of this project, functional requirements, system design, challenges I faced, and key learnings from the experience. Here my contents, introduction, system design, working and implementation details, live project demo, challenges and solutions, and the conclusion and learnings. Topics I learned in this internship, introduction to C language and the conditional statements, loops and operators, arrays, pointers, function and string, storage classes, and triposes and macros. And these are all I learned in the introduction of C language and about the main topics. And these are the where I more use in the implementation I learned in the uh, lab that I implemented on this introduction to implement embedded systems and microcontroller. I use the softwares like MPA Lab IDE, XE8 cross compiler, and Pic- um, PixSim Lab, and introduction to various peripherals of PIC 16F8 877A, and also various peripherals of PIC 16F8 877A, like used in for interfacing the project and the requirements for the this project like PIC sim lab and LED switches, matrix keypad, ISR, timer, CLCD, and what is the main of the micro oven, uh, a micro oven system with embedded system controllers. Embedded system controllers means software plus hardware, where the combination of software and hardware tools into a system is called embedded systems. The purpose and the scope of this project simulated real world microwave functions like grilling and other purposes. It was used for cooking and reheating and grilling. Target users integrated into kitchen appliances like where the users are ready to use this product for the applications for the like kitchen appliances. This is the system design. I want to explain about the circuit, and this is the two types of this is the block diagram, and this is the overview of a micro event system. I will explain the each part, each and every part. The main requirements of this this system, npm lab xad and xc8 compiler pixiem lab. In pixiem lab we have some applications and that we have to use that pic 16 f8 877a and 1624 SCLCD matrix keypad and timer to fan buzzer. Here mic 16 f8 cc is the main board that we have to build on that, and 16a into 4 CLCD is representing the overview of the data, and matrix keypad for the controlling the functions, and timer 2 for the setting the time, and a fan for the showing the cooler system, and buzzer for the alert system. The purpose and scope of the project, the goal of this project is to stimulate the functionalities of real microwave oven using a embedded system. The system allows user to select cooking modes like set time and temperature, and as well as start stop the oven All controller to a microcontroller. The project is useful for understanding real system design, interfacing hardware components, and writing efficient embedded C code. System design and components. The system consists of several key components like microcontroller. I have tell in the above in few minutes back. In this system design, microcontroller acts as a brain of this microwave, processing users inputs and controlling outputs. This is the main motherboard of the system. A CLC displays cooking modes, time, and status updates. It indicates the interfacing the applications that we are controlling on the system. Um, Matrix keypad allows you to select cooking modes, input time and temperature. We can arrange the modes with this matrix keypad, that which selection and uh, arranging and allows keeps and an arrangement in different modes. Fan and buzzer. Fan is used for cooling, while the buzzer provides audible alerts if the time is over or indicating error. So we giving that over values. Here is the block diagram of this main function. And this is the block diagram, and this is the simple overview of microwave wave functional requirements and working. Here we can see that magnetron and some diodes and power circuit, IGBT coupler, and PWM for IC. Reset IC can be removed. STM family as 4 inside. Recommended non-volatile memory, key matrix, LED function, recommended MCU, LCD panel, temperature sensor, humidity sensor. Here we can see the overview of the microwave. Uh, Wave stirrer, wave guide, cooling fan. Here cooling fan, antenna, microinverter, magnetron, and capacitor, high voltage transformer. Here is the capacitor, uh, control panel. Here you can see this metal mesh window that for the door. This is the cooking cavity that which helps for this in the microwave. Now we can see now working system of the microwave uh, wave. Now we can see that the overview of this micro oven. Here we can power on the display. Here we can power on the microwave or selecting the power on, getting the supply display power on micro oven messages. We can see this is the interface that which owning the micro oven powering on micro oven. After that, there are the different modes, cooking modes, macro mode, standard cooking, grill mode, grill based cooking, convection mode, temperature based baking, start mode, directly start with oven for 30 seconds. Here is the user input mechanism, matrix keyword for input, SWM and SWM call, key for selecting modes, setting time and temperature. Here we can see micro grill convection start. This is the options, the functional requirements and working for the system. Power on screen. The cooking modes we can the select different types macro grill and convection start selected with the keypad. User input set time and temperature using the keyboard keypad, the which values are displayed on the LCD. Starting mode, initiate cooking for default time for 30 seconds if no custom input is provided. If you left the food on the uh, without instructions, it will starts after 30 seconds. Implementation details of this feature. Uh, the project was developed by a C language development, hardware components, microcontroller, matrix keypad for user input, for the giving implementation allowed to the code for this CLC for status updates where what the uh, temperature on the taking that in a different modes that we selected, and giving the information about that relay and power supply for controlling microwave operations, relay for the mode which switch on off conditions, power supply for the operation, buzzer for alerts, for the the micro time is over or getting a wrong errors, giving wrong values, like that implementation, software implementation, programming for logic control, for the logic we build and implemented on this board, timers and interrupts for precise cooking control, at which for the certain time, and for the cooking for basic temperature or the times for respective time to cook food respectively, for perfect state machine model for handling different cooking modes, grilling or rearranging or reheating, like that. This is the live project demo. Uh, we can see that these are the functions we build, and that we have uh, built on the board. This is the LCD, and this is keypad. This is the cooling fan, and this is the relays. This RTC, something power supply. This is the serial and keypad. These are the resistors and capacitors are placed in this EEPROM, and this is the microcontrollers that we have built for the uh, in this board, but for the applications we can see more and more in the live project demo, that we can see that and this is my code that which I executed. Here are the different profiles that in are written in the C language, and some profiles, and this is I am now running, and this is the interface. I reloaded last, and the it was on. It is was showing micro gill convection start. Now I am to start the system. So I want to click number one. So mm, it was it shows the power 900 watts, and I am setting the time. Now I am clicking that 2 seconds. It was showing clear and a hashtag for enter. So I click the clear. So it was clear. It was showing 0. Now I am clicking 5 seconds. It shows 5 seconds, and I am entering the hashtag. So the cooling color was started, and time was started. The time was started. Cooking time up. So next after there are options like micro grill convection start. So I want to show that another step, that which to grill. So I am again setting the time 5 seconds, and it was started again, and it was grilling second time, and after time it was showing the options 4, 5, 6 for a start, resume, and passive stop. Here I am checking the condition start and resume, and it was adding the time again, and uh, I was just again start. It was adding some time. So I passed the time. It was passed. Uh, Here we can see the caller was stopped. Again, I want to show this another step, that fix stop. So it was stop. Micro gill conversion gateway has come again to first position, and here I am to setting the third option. Here I am entering the temperature. Here I giving a 260 degrees, and I enter valid temperature. So we have to know connection, and we have to that basic idea on the temperatures. So I want to start, and the micro oven again start. It was having that this is the main interface of the project. We faced challenges and solutions, timing accuracy issues, time accuracy issues that which the food was not reading or the get started fixed using optimized delay functions. This was fixed by using optimized delay functions like functions which you can use for the time accuracy issues, display flickering solved using proper LCD refreshment techniques. If we that showing perfect time and temperature issues that we can see on that board. User input lag used debounce techniques for keypad like entering the options or re-entering the modes that like on that way of time kind of that conclusion learnings gained practical experience in embedded system development, improved debugging and hardware interpretation skills, scope for improvement, adding IoT convenient for remote control. That the project helped me gain hands-on in embedded systems, improve my skills in hardware interfacing, debugging, and on the writing efficient embedded C mode. Moving forward, I would like to enhance my project by integrating IoT features for remote control. Uh, uh, like these are the functions that which in these learning these classes I was um, this is the main challenges and solution conclusion learnings that which I faced in this platform. Uh, Thank you for extremely trainers and mentors for giving this opportunity. And I submitted my YouTube link in this provider in my submission.